We're going to start on page 229. We've already completed the check yesterday. So quick refresher there. Our slope is our rise over run. In this case, our rise is actually going down 3. You can't leave the classroom. You can grab a piece of paper though, or come prepared. There's paper back by the fan. You see the fan back there? All right, so it's going down 3. So we had a -3 and over 1. Well, -3 divided by 1, Marquand, is simply what?
25.
Not -1. -3 divided by 1 is -3. That's what our slope was, which is m. So in our form y equals mx, we put the m here. And then our y value where our line crossed through the y-intercept was what? What did we say it was? 2. So we wrote +2, because if it was at +2, if it was at -2, we would have written -2. All right. So now we're going to do something similar, except we're going to use the verbal descriptions of things. So here, we have to remember that the slope represents the rate of change. So M, we have been dealing with our rate of change and our slope all along, right? Good grief. Can we please be done? I'd like to be done here, and the sooner we can get through here, the sooner we can be done, right? We're so close to the end. Marquand, what do you need right now? What do you need right now? That's my question. What do you need right now?
I grabbed my pencil. I'm wiping off my pencil because I stepped on it.
Gotcha. Okay. I was just confused. Bamboo. Oh, sorry. Slope is our rate of change, and the y-intercept is our initial value. So however much we start at, that's our initial value. So if something has a fee to it and then a rate, so maybe if you joined a gym and they charged you a fee, that would be your initial value. Okay. So like on our problems before, when it asked you how much it cost at 0, some of you wanted to put some of you wanted to put 0, but it actually started at like 500, I think was the problem on our first quiz. That was our initial value. That is our y-intercept. Okay. So that's where it's starting on the y-axis when x is 0. That's why they call it our initial value. So bamboo is one of the fastest growing plants on earth. Suppose a bamboo seedling is 5 centimeters tall. So what does a bamboo seedling 5 centimeters tall have to do with the rate of change or the initial value? Which one of those things are we talking about there, Jairus?
One sec. So that would be the initial value.
That would excellent. That would be the initial value, which we know is our y-intercept. So we know B is equal to the initial value. So the initial value in this problem, B is equal to what? 5. Is that going to help us? Absolutely. And it's going to grow at a rate of 6.5 centimeters per day. So this is giving us our rate of change. Our rate of change is equal to our slope. So what is our slope equal? 6.5 centimeters a day. Perfect. Or 6 5/10 or 6.5. So the slope is our change in height, 6.5 centimeters, divided by our change in time. Well, they gave us that time as 1 day. So you could just write this as 6.5, right? What if they told us our rate of change was 6.5 centimeters every 2 days? What would you have to do? Careful. You would have to divide by 2, right? Because 2 would be in place of this. And that is what you had to do on the quiz yesterday. Wow, you guys did a lot yesterday. That's what you had to do on the quiz yesterday, because we divided y by x for some of those, right?
Yes.
To find our unit rate. Remember your 6 divided by 4 to get 1.5
Oh, yeah, no. For the scarf.
for the scarves, the knitting. All right. And what is our y-intercept? Where is our initial value? What's our starting point was 5 centimeters, right? So now we're just simply going to put m and b into our equation. Do you remember our slope-intercept form? Y equals mx plus b. So now we're going to put this in for m and this in for b. Can you do that?
Yeah.
I hope so.
Wait, we're almost done.
I hope so.
Oh, right.
That's it. That's our slope-intercept form of this line. Do you see where I got those from? Do you see how we have to read and understand what we're reading in order to know that that's our initial value? Can you guys see that okay? So here's our example now on page 230.
Not sure I understand.
I'm not talking to you, Siri. Student council, this is page 230, the example for write equations in slope-intercept form. Is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. Write an equation in slope-intercept form to represent the total cost y for printing any number of shirts x. So we need to find our initial cost. So the slope represents the rate of change or cost per t-shirt. What was the cost per t-shirt?
$5.
$5. So that is our,
No,
that's our rate. That's our
Yeah.
change.
Here's
If
what I
it's
found.
$5, Siri, stop talking to me. You're telling me about basketball players. So if it's telling us it's $5 for each shirt, that's a rate of change. It's changing by $5 for each shirt. So that's our slope. So m is equal to what? 5. Now, what's the other number that they gave us? It says it costs $20 for the design. So that must be our initial cost, right? It's not going up $20. It's just costing that for the one design. The one-time charge for the design is how much? $20. So that's our initial cost. So what does B equal? 20. So now we're going to use that to write it here. So the slope is $5. The y-intercept is $20. If I'm putting m in for m, what is m? 5. And what is x? I'm sorry, b, not x. B is 20. Now, if I wanted to know how much it was going to cost me to make 72 shirts, I would put 72 in for x, right? 72 times 5 plus that initial $20, and it would tell me. That's what that equation represents. All right, let's read the check, and then we'll try the check. Faith is saving money in order to purchase a new smartphone. Question. She started out with what? If that clue started out with tells me that's our initial value, which is our y-intercept, right? So B is 30. And is able to save an additional $15 a week. $15 a week or per week, that's a rate, right? Our rate of change is going to be our slope. So what is our slope here? The other number, what's our other number? 15. So can we write an equation in the form y equals mx plus b? So do that real quick. We're simply putting in numbers for m and b. What's our new coefficient of x?
Oh,
What is it? 30. Is it?
no, it's 15.
It's 15 because we need m to go in front of x. So our rate of change here is $15 per week. So our rate of change is always our slope, and that's what we put in front of x. So I have to put 15 here. Now, can I just write 30 like this? Plus 30, because 30 is positive or negative? Positive. So be careful there. Questions on that check? Remember, all of this is also in your reveal side of your McGraw-Hill app. So if you need to go back and fill these in, go into module 4, select section 5, and you can go through these same things, filling them in on your own as well. No, that's not it. We're almost done now. Learn, write equations in slope-intercept form from a table. All right. You can write an equation that represents a non-proportional linear relationship in slope-intercept form from a table of values. Here's a table of values. We have x values and y values. First, we would determine the slope. The slope is the rate of change. Remember, it's the change in y divided by my change in x. That's slope. Hopefully, when I write it down, you're writing it down, and the more you do it, you're remembering it. Right, Miley? So our change in y here is what? 12. Our change in y is 12. What is my change in x? Every time y goes up 12, x goes up 2. What's 12 divided by 2? 6. So isn't that my slope? So the slope or rate of change in the table is 6. 6 is equal to my m. I'm going to need that to write my equation, right? Now the y-intercept or initial value is what? So when, write this, x equals 0, y equals b. B is our y-intercept. So our initial value is when x equals 0, y equals what here? 10. So in this case, when x equals 0, y equals 10. So 10 is equal to b. So now we can put it into the equation y equals m, which was 6, x plus b, which was 10. Does that make sense? All right. So it's just different ways that we have to gain these information. We did it from words. We did it from just being told. Lots of different ways we're figuring out slope-intercept form. All right, so we have another table. We're trying to figure out the slope. What is my change here? Is it going up or down? First of all, down. So negative what? Negative 80.
What?
So 360 minus 80 is 280. It might have been easier to look from here to here, right? To get to 200, we would have to subtract 80. To get to 120, we would have to subtract 80. To get to 40, we would have to, you guessed it, subtract 80. This should be a constant slope. Or otherwise, this might not be a constant, right? Every time it goes down 80, it's going up what? 2. So what's my change in y?
-80/2.
My change in y is -80. What's my change in x? 2. Now, we could simplify this and divide them both by 2, which would be, yes, which we know is -40. That's all they're saying here. So this is our slope. What letter is our slope in our equation? M. This is equal to M. I keep writing this because you have to remember what it means and where we put it in our slope-intercept form. Okay, so turn to page 232. We're going to continue this on the next page. Yes.
So how do they go from putting numbers in math to letters in math and then?
So we could speak in all sorts of different languages.
There's a triangle from Y and then triangle from the.
That's delta. That's an actual letter. It's the Greek word delta, meaning change. So now you're learning Greek. That's why I write the change as that. Otherwise, I would have to write out the word change every time. But that's why it's important for you to come to class so that you learn that that means change. So you're not like, why is Mrs. Loud putting triangles here? All right. Who do you think started a lot of our math work?
Aristotle.
Yeah. And where is he from?
Greece.
There you go. All right. Find the y value when 0. So when x is 0, that our y is equal to b when x is 0. So in our table, you see when we find x is 0, we find our y-intercept, which is 360. So the y-intercept is our initial value is 360. Now we're just saying that 360 is what letter in our form y equals mx plus b? Which one of these letters, M or B? We already found M, so it's got to be B, which is why I wrote when x is 0, y is equal to B. All right, because isn't that true? 0 times x would be 0, so wouldn't y actually be equal to b? Yeah. So here it is. What did we say our m was? We got to flip back and see on this page. We said our m was equal to what? -40. So that's what we're putting here in front of my x. That's my coefficient. And what is b equal to? 360. So the equation that represents the data is y is equal to -40x plus 360. All right, here's your check before you're going to have to practice all of this. The relationship between the data and the table is linear. If it wasn't linear, could it fall into the form y equals mx plus b? No. Write an equation in slope-intercept form that represents the data in the table. So right away, I'm reading slope-intercept form. Okay, I know I need to put it in this form. I know I need to find my change in y. How do I get from 6 to 3? -3. From 3 to 0. -3. From 0 to -3. So what is my change in y? And I have to divide that by my change in x. How do I get from -1 to 0? How do I get from 0 to 1? And how do I get from 1 to 2? So my change in x is 1. So what is important about my change in y divided by change in x? That's equal to my m, which is my slope. That's my rise over my run. So what does m equal? -3. So far I have y is equal to -3x. Now I have to figure out what b is. Remember, when x equals 0, y equals b. So when x is 0, y equals b. So what does b equal? 3. Am I writing minus 3 or plus 3 here? Plus 3 because it's positive. If it were negative, we would have to write minus 3. Okay? All right, so you got a good chunk of time, close to 20 minutes, to be completing page 235. That's only 10 problems. It's definitely doable, especially because here they want to know what your slope and y-intercept for. These are all in the form y equals mx plus b. Here they want to know what your slope and y-intercept are. And here you're putting your slope and your y-intercept into the equation and writing the equation. Here you're figuring out your y-intercept and your slope on the graph. So you have to find slope, y-intercept, and then you have to write it. So y equals something x something. And now you're finding your, look, here's your constant rate. It even gives you the word. Is our constant rate our slope or our initial value? This is our slope, which means our initial value is what? Be careful here because, well, you could write this both ways, but I would probably be subtracting that many miles per however many hours. But we didn't really do anything like that in our examples, so just try them. This one, you're finding it from a table. So again, you're finding your change in y. Remember, your slope is your change in y divided by your change in x. And just like we wrote on the previous pages, when x is equal to 0, y is equal to b. That's how you're going to figure out what b is. Look here. And you're putting it in the form y equals mx plus b. Okay, so this should be pretty quick. 1 through 10 on 235. Which do you want to see? This one? No problem. So we'll pause it